Okay, in this question we want to find the length of the curve y equal ln parentheses cosine x, where x is between 0 to pi 4. The formula for arc length is as follows. So we have the integral a to b. A is your lower bound, b is your upper bound, square root of 1 plus the derivative of y squared in terms of dx. So let's get started for our question. And the first thing we want to do is determine dy dx. So we want to know the derivative of y. So we have y equal ln parentheses cosine x. So what we're going to want to do for this is actually get the derivative. So we'll have to use chain rule. So in doing so, what we're going to get is 1. So the derivative of ln is 1 divided by your value, so cosine x. And now we need to take the derivative of the inside term, the cosine x. So we'll get negative sine x. So negative sine x divided by cosine x is simply negative tan x. And so the next thing that we want to do is plug in this value here. So for our arc length, so ln, and our bound, the lower bound is going to be 0, upper is going to be pi 4. So 0, pi 4, the square root of 1 plus negative tan x squared in terms of dx. Negative tan x squared is simply tan squared x, and we know there's an identity to this. And the identity is this is equivalent to secant squared x. So we take the square root of secant squared x, it's simply going to be secant x. So what we're going to have here is going to be 0, pi 4 secant x in terms of dx. The antiderivative of secant x is something we should know, and it is ln, absolute value of secant x, plus tan x. And we have from 0 to pi 4, so 0, pi 4. So let me scroll down, we're almost there. So now we're plugging in pi 4. So when we do so, we'll get, so secant pi 4 will be square root of 2. Tan pi 4 would be 1. Absolute value. Minus ln absolute value. So when we insert 0 for secant, we would get 1. Insert 0 here, we would get plus 0. And we know that the ln 1 is simply 0. So we don't need to worry about that. And so our final answer is going to be ln absolute value of square root of 2 plus 1. And this is our final answer. And that's all we need to do.